Okay, right now we're going to talk about discriminant. This is the second half of talking about the quadratic formula. We are in particular going to focus on the on the terms that are underneath the square root sign. We do this because we want to know how many real solutions there are to any quadratic equation. And a real quick way to check is simply to look at the discriminant, which is b squared minus 4ac. Now, how does that tell us how many solutions there are, or how many x-intercepts, or how many roots there are? Well, let's take a look. Three possible things can happen. B squared minus 4ac could be positive. That means there's two real solutions. That means it crosses the x-axis twice. So if I were to sketch in a quick little quadratic here, it may look something like that. So there'd be a root here and a root here. So two solutions, two places where it will cross the x-axis. What if the square root, the items under the square root are equal to 0? B squared minus 4ac actually equals 0. Well, that means there's one solution and it occurs twice. So that means the vertex is right on the x-axis. So it's a double root. It occurs twice. So there's two solutions, but they're both the same number. What happens though if b squared minus 4ac is negative, meaning that it's less than 0? Well, you can still continue to solve, but then you have what we call imaginary solutions. So what's your quadratic look like? Well, it might look something like that. Or it could look something like this. So it's still a parabola when you graph it. It just never crosses or touches the x-axis. So we say there's no real solutions. We will get into imaginary solutions in section 4.8. So here's the question. How many real solutions does that quadratic have? I don't actually want to know what the solutions are. I just want to know if there's any real ones. Go ahead, look at b squared minus 4ac. Now, again, we have our a, which is 2, our b, which is negative 3, and our c, which is 7. I'm going to take that information, I'm going to put it into that little tiny formula. The quantity negative 3 squared, again, notice that I use parentheses here because I want to square the entire amount, minus 4 times 2 times 7. So when I go to solve, I get this far and I'm like, you know what? I don't even actually care what the answer is because I know it's a negative. There's a negative discriminant, so there's no real solutions. So what I have then in that case is something that would graph either something like this or like that, where it's not going to touch or cross the x-axis. I want to do another word problem with you folks before I let you go here. Let's do, we did in our quiz over the first part of chapter 4, we talked about a diver going off a springboard. So let's do another springboard one. So a diver dives from a 10-meter springboard. The equation given now is slightly different than the one that I had in the quiz. So negative 4.9 t squared plus 4t plus 10. So the diver starts at a certain height. We're going to say 10 meters because that's what that is right there. We'll go up a little bit and then go down into the water. And we want to know, this is time going along this axis, what time will it be when the diver enters the water? Okay, I'm going to leave my picture right there. What is her height when she enters the water? Take a look at the picture. If you said her height is 0, you are correct. So we can put in a 0 for our equation. Here's our equation right up here. Her height is 0. So 0 is going to equal negative 4.9 t squared plus 4t plus 10. From there, go ahead, get out your quadratic equation, plug in your values. A is negative 4.9, B is a 4, C is a positive 10. So I put those values into my equation. Simplify your radical. We can see that we're going to have two real solutions. Notice though, I said, what time does she go into the water? I'm going to pause my solve right here because take a look. There's only one solution there. Well, if I continued my quadratic formula or quadratic equation and when I solve, I'm going to find that I'm going to get a negative time. So I'm going to have one solution that's positive and one that's negative. That's okay in a mathematical standpoint, but in the real world, you can't go backwards in time. So we're going to just toss one of our solutions out. So here we go. We're going to simplify this. So I've got my 16 from 4 squared, multiplied these together. That becomes positive 196. And simplify. Now, 212 is not a perfect square. So I'm going to go ahead and split this into the two solutions because I'm not sure which one's the one that's going to work. So I have the positive and I have the negative here from right here. So it's plus or minus. So that's where you split it into the two possible scenarios. Grab your calculator, go ahead and solve. So you're going to get x is negative 1.08 seconds or x is positive 1.89 seconds. As we've said, in the mathematical world versus the real world, those are two different things. We don't go backwards in time. So the only solution that makes sense is that one.